Hello, what's up guys? Welcome to my tutorial about Ardupilot and PX4 software in the loop from 0 to 100 in 1 hour or maybe about 1 hour. Uh, Basically, I imagine that you have mm, already know what is Ardupilot PX4, what is PX devices, and what is software in the loop, and this basics. I already expect that you know all these topics, so I'm not going to cover all of them. So I hope you know them, because we already know that if you want to do software in the loop, it means that you're an advanced user, not just a hobby user. Okay, but before starting, I want to have a very short briefing, short introduction, and just clear everything before starting. First thing is the difference between Ardupilot and PX4, and then very short description about what is software in the loop. Okay, first the introduction. You already know this device. This device is usually popular with the name of PX. This is the hardware. So the processor, the electronic circuit, the IMU, and everything is inside this hardware. It's just like your computer case. But what you install on it is the firmware. You can install PX4 or Ardupilot, just like an operating system that you install on your computer. For nobody can say that which one is better. Each one has its own benefits. For example, just to make things clear, Autopilot is known to be more reliable because it's a long time. It's been out there for a long time, and many people are working on that, and it's being used in many even industrial and maybe military purpose as well. So it's very reliable, but with much less. For example, Autopilot is reliable, more reliable, but it has less add-ons. For example, PX4 has a lots of features for VTOLs, vertical takeoff and landings, or many modern and unknown frames, or many user-friendly or new and modern features. But Autopilot maybe don't have them yet. So it's based upon your choice which one you're going to use. I prefer to use both of them for my purpose. I usually test both of them to see which one is better. If all I want is satisfied with Ardupilot, I go on with Ardupilot. But if I need something I need that there is not available in Ardupilot, that's only available in PX4, so definitely I will continue with PX4. Both of them are great and both of them are reliable enough. The hardware and software and computer are communicating via a protocol called MAVLink. MAVLink is a protocol, micro air vehicle communication protocol. We don't need to go inside and see what's happening inside MAVLink. It's just like a protocol, for example, the HTTP protocol that you're using to connect to internet. So we are only using MAVLink to communicate. Just like the firmware, you can use many different ground control software, or you even don't have a ground control software. You can use Mission Planner, APM Planner, QGroundControl, Mav Proxy, Tower, or any other mission ground control software that you have built. The most familiar one is the Mission Planner and QGroundController. For using PX4, I mostly recommend using QGroundControl, and for Ardupilot, I recommend for programming and setting the parameters and for initializing and this kind of stuff, use Mission Planner. But for your daily use, for going to the mission field or maybe sell it to another third party, then you better use QGroundControl, because you can install QGroundControl on your cell phone, on your tablet. It's much more user friendly, but Mission Planner is more advanced. I kind of like Mission Planner more, but for a user that's going to just fly the vehicle, maybe QGroundControl is better. Enough with the introduction. And this is the short briefing as what is software in the loop, why we do need to have software in the loop. Maybe we are not familiar with the mission that we are creating. Maybe we have done some manipulation on our firmware. We have changed the flight modes. We have changed the, I don't know, the criteria and conditions, situation, the mission, the PIDs, anything. Or we have created a mission and we want to check what will happen inside that mission, where we are going to pass inside our mission leg, or what will happen if in the middle of the mission I lost my signal, what will happen if my battery just run out. You can simulate those without costing you anything, without crashing your vehicle down. So you can simulate the flight here on your computer. In that case, all of the things that is processed inside this hardware will happen inside your computer. So the computer thinks that it's a hardware, and also it simulates a model of your aircraft. You can model your own aircraft or use some custom aircraft out there. So in this case, the mission planner gets this sensor data from a simulator and send the commands such as control surfaces back to the simulator. The simulator can be either flight gear, I don't know, Gazebo, jMavSim, and also explain. This is the architecture behind the scene for PX4 and this one for Ardupilot. Just the same, everything is the same. Everything is happening using UDP. Okay, and for the last thing, your operating system. You know, many of you might wonder why most of the advanced users are using Linux, so why they are not using Windows. You know, I myself usually use Windows or even Mac, but after many experience, after maybe struggling with these things, especially struggling with software in the loop simulation with Pixar, I came to this conclusion that it's useless. We shouldn't use Windows. I don't say that it's impossible. It's possible, and also I did it. I did it after a long time with it, but I'd say it doesn't worth it. You at the end you say, okay, I should have gone to Linux, I should have used Linux or even Mac, but Linux is better because there are lots of things already available in Linux for this kind of process. Linux is much more friendly for programmers. Everything is open source, everything, the command line, everything is here. But inside the parentheses, something I want to add. In the new version of Windows 10, there is a capability that you can really simulate Linux interface inside your Windows. If you search on Google, you can find many things about that. So you can have Linux simulator in your Windows 10. But still, if you have enough space on your computer, I recommend you to install a virtual Linux or even a complete Linux for yourself. You won't be regret it. You can use VMware or virtual simulator. Just you can go to Google, for example, VMware workstation. And there are lots of other simulators like this. In Mac, you have VMware Fusion, I guess, or you can use virtual system or any other things. You can have how this works is that you are using Windows, but inside Windows you have another operating system such as Linux. So you have a real Linux inside your Windows. But keep in mind that you have to share the system resources between your operating system. So if you are going to use Linux for hard simulations, better to have more share, give more share to the Linux, and don't do anything heavy on your Windows while running Linux. So if your system is not powerful enough, don't use virtual system. Just install a fresh copy of Linux, give 20 or 30 gigabytes to your Linux, and you're good to go. So the last advice was that don't go to Windows for this kind of specs. Stick with Linux and you will be good to go. Okay, we continue. I'll continue my recording in Linux for you, and I will tell you what did I do from the 0 to 100 for software in the loop with Ardupilot, PX4, Gazebo, jMavSim, flight gear, and everything else you need to know. Okay, here we are inside our Linux operating system, a fresh installation of the Linux you have. Everything is fresh. I didn't do anything with this Linux yet. Okay, as I told you, there are lots of tutorials out there that you can use out there, both for Linux and both for PX4 and Ardupilot. All I'm going to do is just follow you through this course, and I haven't done this yet in this computer, so we may find many errors during this. So keep patience, be patient, and we are going to solve those errors together. First, let's start with PX4 because it's much more challenging. There are some source files out there. This is ROS, the Robot Operation System Melodic. This is the most complete version. Go on this page. I put the link for you in the description as well. Save this file on your desktop or any other place that you want. Ubuntu, Sim, ROS, Melodic. This is the most completed one out there. This package, this shell file will do everything for you. It will install almost everything that you need. So just you cd to the desktop. I'm going and find that file and call that file using the source command. It will take much long time, very much long time especially if you don't have good internet. So I'm going to pause the video here and let everything happen for you. After it all finished, as you can see, it's finished, but I totally recommend you that you do the command again to make sure that it's installed and there is nothing left, because somehow maybe internet connection or some connections be blocked. So do it again to make sure that nothing is left. For example, I click here, I'll go to desktop, again run the command for Ubuntu, and let's see what will happen. If you have already installed everything and nothing is less, everything will be happen so fast and there won't be anything new installed. Just like here, you see 0 upgraded, 0 new installed, and 2 not upgraded. I don't know why. I'm not an advanced user in Linux, so many things that happens here, it's the first time that I'm seeing, so don't expect me to tell you everything. I'm just following these tutorials here from Tayyip Insar and some experience that I had. Okay, after this, a new folder will be created, which is catkin_ws inside your root directory. I'm going to create a folder in root directory and call it PX4 and then cd to PX4. And then I'm going to clone the PX4 firmware from GitHub to this folder. We are going to need the firmware of the PX4 inside our computer. Just simply search PX4 GitHub firmware. And if you live in a country that, such as me, that many things it's blocked for you based on sanction or anything like this, make sure that you have VPN connected so you won't face with any problem. Come to clone and download and copy the URL here and simply use the command git clone and the URL. It shouldn't take much time, maybe 2, 3 or 5 minutes, depends on your internet, but I'm going to pause the video and just try to monitor everything that you don't face with any errors based on your network error or anything else. Okay, that's done. We have the PX4 firmware ready for continue. Now we go to the tutorial and do the next steps. You never can expect what's happening the next because no two computers are the same. You may face with many errors, and here I don't expect what to see, what errors we'll be facing. So be patient. Next step is to download the QGroundControl. First, we're going to use QGroundControl with our system. Simply go to the QGroundControl web page for Ubuntu. First, you need to do some changes with your user privilege and user mode. Just copy and paste the commands, no need to see what it is. Then you have to remove the default modem manager. It's a way that Linux has to communicate with USB devices, but QGround may conflict with that, so you need to remove it and install something else. Okay, then another library for video streamer or something like that. Some of them take a little time, so be patient. And after that, you have to download the QGroundControl.app image. Simply click on it and download it. Download it, for example, in your desktop. After it downloads, you should change access file permissions with chmod or chmod, whatever you call it, I don't know. So after copying the file to desktop, you're going to cd to desktop and do the command for chmod or chmod, I'm not sure what's the pronunciation, I've heard both of them. Then you're ready to run QGroundControl. You can run it with the command or just simply go to your desktop and double click on the icon. And just a hint for you, if you want to paste something inside your terminal, use Ctrl-Shift-V. Ctrl-V won't work, just use Ctrl-Shift-V. And this is QGroundControl ready for our next steps. This is the interface. Okay, let's create another terminal tab with Ctrl-Shift-T. Now we are going to cd to our PX4 directory, first cd to our root and then to our PX4 directory, and then cd to the firmware directory. This is the list of files available in firmware. And the next step here will tell you some additional tools. It's not important. You can all this tells that you should download the QGroundController or another editor and IDE such as Sublime Text or Visual Studio. So it's not critical step. We will go to instructions about the build. We should build the PX4 inside our computer. And we are not going to build it to install it on a hardware. We are going to build it for software in the loop, so it will happen inside our computer. There are different versions of build, as you can see here, building for Quad-rotor, building for plane, building for VTOLs, building for Gazebo, jMavSim, flight gear, and so on. For the most exciting one, I'm going to use a standard VTOL. A simple command make PX4 underscore SITL Gazebo standard. Almost sure that it won't happen and we will face with errors. So I pause the video. So you see that we have error here. But the nice thing is that it already tells you the error. It says I didn't find the EM module. So use this command to install EMPy with pipe3, which is a pipe install some Python packages. And we need to have the sudo. It says that before that you have to install the Python package installer so you can install using pipe. Very routine and straightforward steps here. Just see what the system is telling you and you just do what should you do. This will take a while and I'm going to pause the video again. Maybe not taking that much time. Okay. I'm going to test again to see if that it's work and install it. Okay, we're ready, and again we are going to use the make command, but again I'm sure we are facing with more errors because I have done it in another computer. And before building again, I'm using the command make clean to make sure that no corrupted files remained. You see another package is missing, which is TOML or TOML. I have no idea what it's working and what it's for. Just I'm going to install it. Done. Again, make clean and make the PX4 again. Definitely we will face with error again. NumPy, another package that is missing. I have no idea why they are missing. Maybe the PX4 guys forgot to put this inside their shell files, or I don't know. Okay, make clean and make PX4 again. You see, everything is based on try and error. Everything works with try and error. Another package is missing, JNinja 2. Done. Again, make clean, make PX4. Programming is the game of patience. And who has the most patient guys, be the most patient guys will success eventually. Good news that we are progressing, but definitely again it failed. This error that you see here is not just simple like before. I struggled with this error for 2 days before I could solve it. So I'm going to tell you the solution here. This is the solution after it took me 2 or 3 days to find the solution. You can see this is the error, and this is the form that they were talking about this error. And it's found out that a library about the GStream, about the video streams, I guess, is missing or not. It's not the correct version, I guess. So you should install all the versions here. And I have no idea what it means. Good, bad, ugly. Maybe the video quality or something like that. It's all I know is that it's about the video streamer. Okay, and just do all of them one by one and make sure that they are being installed. And again, make clean, make PX4 software in the loop. This time I think we will success. I'm not sure. But if it takes so much time, it means that we are progressing, because this step for the first time takes a lot of time, because it's building the whole PX4. So it means that we are progressing because we haven't faced with any errors yet. While it's being made, I'm going to tell you another solutions that may have been the case for you. If you still find some errors, go ahead and install these tool chains available for different systems. For example, this one is the common dependencies only for Raspberry Pi, but when you install it, maybe some packages are available in that. So if you install that, your package problems will be solved. So go ahead and install those. Maybe it will help you. These are the steps for the simulating with different simulator. For example, jMavSim, Gazebo. I'm the fan of Gazebo. jMavSim is very simple, but maybe sometimes it works for you. There are very good documentation here. Once you could successfully build one of the systems, that's everything is ready for you. Then everything is ready. Then you can go to different pages here, to the different commands and see the results. The hard part is the first part, that you make the system, prepare the system for your purpose. Then it's just a matter of copy and pasting these stuffs. Okay, it's taking a long time. It means that we are going through and everything is okay. And I'm going to pause the video here and we'll come back with you when everything is ready. And just one more thing, you see that there are different commands for different simulators. You can test all of them if you want: plane, VTOL, tilt rotor, even vehicles, cars, or I think even they have submarine, yes, submarine. And you can change the world. You can model the worlds, making trees, runway, streets, mountains, and everything. The commands are uh, all of them listed here, so you can use them easily if you need them. Very good documentation here, but the hardest part is to make it work. And by now, we have completed the hardest part, which is building the PX4 by itself. Okay, I'm going to pause the video and we'll come back for you. Okay, right now you see that the gazebo is run and it's communicating. The software in the loop is communicating. Don't worry about those errors. For the first time, it will take a long time to communicate. Maybe, I don't know, 10 minutes, 15 minutes. But you see your model here. It's inside the gazebo, our VTOL. It's very inspiring. And this is the QGroundControl. I let the QGroundControl be open and waiting for the connection. So I let it open, and immediately after the make complete, it immediately connected to X-plane. Now we arm the aircraft and command it to take off. Successfully take off, and this is the moment that you can have brief and enjoy the view. Your aircraft is flying but in a simulated environment, so you don't risk anything. Now I'm going to transition into forward flight. Very great, it's working very great. You can command it back, return to launch. Now it's going to return while in a plane mode. Very great, you see it's turning. These are very useful if you know. You can change the mode to multi-rotor, so it will brake and switch to multi-rotor mode. The airspeed will reduce and ground speed also. Pitch up for braking and will hover. Then you can click on land and land with the multi-rotor mode. It auto land. Until it lands, let me tell you something. My frame rate is a bit low here and will be lower later because I haven't installed the driver yet. So I will tell you more about the driver if you are new to Linux. Now everything is available for you in QGround. You can change everything. You can change the model, wind, environment, or change the mission inside QGround. Everything is ready for you. Go ahead and play with everything here to learn more. Okay. You can use other things such as jMavSim or any other simulator. And you can also use the ROS, the robot operating system. It's a whole other stories you can use it. Okay, enough with PX4. Let's continue with our Ardupilot. For Ardupilot, there is a very great documentation here by this guy. I don't know, Eric Johnson, I think. Very great. I'm not showing you anything. Everything is clear here. Everything is documented very well and great here. So I shouldn't say any word. Everything is just a matter of copy and paste. There are lots of tutorials here from the beginning. You can click on the first one, installing Ardupilot and Map Proxy. And each topic has a video tutorial as well. So no need to talk by me. So you just go click on the link and there is a YouTube tutorial for that. Very great tutorial. I watched all of them and it was very useful. And there is also a documentation page that you have all the commands, links, and everything you need. Just go ahead and check all of the videos for these guys. They are great. They are one of the best videos I found out there for robotic and UAVs. Very great. Intelligent quads. Okay, let's go on with the commands here. Nothing out of this document. Everything is copying and pasting. So I see it to the root of the directory, and I'm going to git clone the Ardupilot. Ardupilot will create a folder for itself automatically. Just copy and paste the commands here. Again, it will take about 2, 3, 5 minutes based on your internet connection. I'm going to pause the video, and when it's completed, I'll come back to you again. Done. The next step is we cd to the Ardupilot directory. You can check out with a specific version, for example 3.6 for this guy, but I prefer to stick with the master here. If you're going to stick with the version and don't face with any compatibility issues or changes in the future, you can check out with a specific version of the Ardupilot, but I'm going to remain on master for the sake of tutorial. Now you have to download the submodules, git submodule update -init -recursive. This way it will install all the submodules that Ardupilot needs, such as mavlink, mavproxy, and so on. Because we have already installed many of these while we were installing PX4, so as I told you, most of them are the same, they have the same dependencies. This step will take a much shorter time, but if you haven't built for PX4 and just came to Ardupilot directly, you will find that it will take a long time. After you install these dependencies for the Pythons and just as I told you, most of them we already have, so everything will happen quickly and will be installed quickly because we already have it. Then we have to add some paths for the include directories and directories for including the libraries of the Ardupilot. We have to add those lines to our bash rc. We have the same topic also in Windows as well, but here is a little bit different. After the dependencies and the Python dependencies finished, we are going to copy. Still these are left. I'm just speaking ahead of the scenario. Okay, now we are going to open the bash rc file of the Linux with an editor. And we are going to add these two lines, export paths, to the end of this file. Simple. And we'll save it with Ctrl S and close it. To make sure that to make it affect the change be affected, you should log out and log in again or rerun the bash rc file. So it's simple to rerun the bash rc, and to make sure that it's changed, we're going to open the editor again, and yes, it's changed. Okay, run the bash rc again and go ahead. Next step is to run the software in the loop. Ardupilot and PX4 have a little different architecture. In Ardupilot, there are different folders for each frame. For example, all of the Ardocopter multirotors, multirotor coaxial copters, I don't know, VTOLs. Many helicopters are in the folder of Ardocopters. The plane is in the folder of Arduplane. So you have to cd to the specified folder. But in PX4, no, everything is in the same folder. So based on the settings, you select your frame. It's very simple. cd Ardupilot Ardocopter simvehicle.py, and we face you see our Ardupilot has started working. The panel that you see on the left is telling you that the Ardupilot is being ready. EKF, which is extended Kalman filter for IMU, it's working. You can send command here. You can change the mode here. First we should change the mode to mode guided, and then we can take off. The mode is unstabilized, so first we should change it to mode guided. But right now you don't see any graphics here. Everything is happening inside this console, but the Ardupilot is working. The next step is to use QGroundControl for some graphics and to see what is happening. So what will we do? We'll install QGround. We already have done it, so we don't need to do anything. We don't need the second step, so we proceed with the third one. Third one already says you have QGround, Ardupilot software in the loop, and you are going to connect this to Gazebo simulator. Okay, again there is YouTube tutorial about it. You can go on with that. But you can install, there's a command for installing Gazebo. We have already installed it, so it won't take much time. We just copy and paste for the sake of tutorial, but you already have it. No need to install anything else. The setup keys, software list, install Gazebo, and updating. You don't need to update. If you haven't updated your system yet, go ahead and update. But if you haven't, I've just recently updated, so I don't need to do that. But if you haven't, just do the update. Install the Gazebo. Again, it won't do anything because we already have the Gazebo. It will go on and check and say, okay, you have Gazebo, no need to install anything else. The Gazebo plugin. There is a plugin for Gazebo that does everything you need to connect the Ardupilot to Gazebo. Everything is happening behind the scene without even noticing by you. So you install the Ardupilot plugin for Gazebo. Again, cd to the plugin. You can check out. This guy has checked out with developer. Okay, we can check out with developer or remain on master based on your process. Then we are going to create a folder called build inside our directory. Then we cd to the build directory that we have created. Now we are going to use the CMake file that is already available in the higher folder. CMake is just a list of telling the computer which file to build and how to build them. CMake is making everything ready to build. Then we are going to use make-j4. -j4 means use the 4-core processor. If you don't have 4-core processor, it will no effect. This process will take really long time, maybe 15 minutes, 20 minutes, 30 minutes, I don't know, based on your computer performance. It will take a long time. Okay, it installed. No, not 15 minutes, it was much more less. Then we are going to add another line to our path to bash rc here, but this time we're going to use the command echo for that. Just copy and paste the commands, no need to deal with anything. And again, run the bash rc to make those effects. The last step is running the simulator, but definitely we are going to face with an error. Okay, as you can see, we find an error here because I have expected this error, but yet I don't know the solution. We will find the solution with the help of each other. Just make sure that you haven't skipped any steps here. The exports, the path, the user, the bash rc file. Make sure you have done everything. I'm going to pause the video and then I will tell you the result. After doing a lot of research, I found the solution in this page. It says that one of the packages that I have, which is called ignition mass version or something like that, has a conflicted version and compatibility issue. So to fix that, you can specifically upgrade that component or just upgrade all of the components that you have. Sudo apt upgrade. Then everything will be upgraded and you're good to go. And after the upgrade, it's much recommended that you update as well. So just doing a simple upgrade solves everything here. I'm going to pause the video here. Maybe it's not needed. Okay. Now we're going to go back and run the Gazebo again. Great. This time it's working and Gazebo is running. And don't panic if it took a long time for you. Maybe it takes 15 minutes or even 30 minutes here for the first time. Right now the Gazebo is ready, and as you can see, my frame rate is very low. And at first I didn't know the reason, and the reason is for graphic adapter. I will tell you what to do for that later on. Again, you have the simulator in Gazebo, a runway, and a very simple land. To run the QGround, we simply, when the software in the loop is happening, I come here and open the QGroundControl, or I can open it from another terminal. And it's hardly recommended that you first open the QGround. First open the QGround, then open the Gazebo and Ardupilot. The first step is to open the QGround and make it ready. Then run the Gazebo simulator. And in another terminal right now, you should open the software in the loop, which was the first step that we done before. Now the simulator and the QGroundControl are ready, and the next step is to run the Ardupilot simulator. Ardupilot firmware, sorry. We cd to Ardupilot, Ardocopter, because we are modeling a copter here. This is a command. SimVehicle. SimVehicle is a file that does all the software in the loop things for us. You can see simvehicle.py. We're going to use Ardocopter and Gazebo IRIS world. And we also need the console for us. Simple, just copy and paste. And if it's the first time for you, it will definitely take time. But I have already built it. We have already built it together. You see, it didn't connect it to QGround. I have no idea why the connection refused. I have no idea. So I'm going to do it again to make sure what is happening. Again, we face with an error here, I guess. No, it worked. This time it worked, I guess. Waiting for heartbeat. It worked. This time it worked. Maybe that was a communication problem. I don't know why it works. As you can see, the console is telling you that the extended Kalman filter is ready, and the QGround says missing parameters. Maybe they haven't still loaded, but they will. Wait for it. When you connect for the first time, wait for everything to be ready. You see the train load is in progress. It's loading the train out. And now go to arm the vehicle. Great. The motors are spinning. And then I command it to take off. You see there's just some small changes the way you do it inside Ardupilot and PX4. But the same concept here. My computer is very slow because of the graphic card drivers. I slide to take off and boom, you're taking off. Great. And it's already in the guided mode. Everything is okay, it's working, but my graphic card is making me crazy. It doesn't work. So that was the concept, you know the concept here. After I install the driver of the graphic card, everything is ready. I click on return and slide to confirm to return. Return means it will climb a little, come back to the waypoint to the home location, which is already here, and starts the descent. You will be seeing the quadcopter at its last seconds of touchdown. Voila, and touchdown. Great, let's go to the next step. The next step is to install ROS, which is Robotic Operating System. And there are lots of tutorials that I'm not gonna cover because it's useless. The best tutorials out there is available in this page, and I will put the link in the description. Just go on and follow everything you saw here. All of them are great and very great tutorials. What I'm going to add in this page that it's not available in that tutorial is flight gear. Flight gear is a much more advanced simulator that you can model the buildings, the runway, the real world. So I'm going to install flight gear just simply with doing the command sudo apt-get install flight gear, and it will take a huge amount of space. I think, I don't know, but maybe 1 gig, 2 gig, 3 gig, I don't know, maybe 5 gigs, I don't know exactly. I'm just going the command and let it install. It may take a long time, but it has a better simulation environment. You can use third-party plugins to improve your environment. I'm going to pause the video and wait for it to finish. Done. As you can see, the flight gear installation has finished. And the command says that there is already an example file for connecting the Ardupilot to flight gear. Before processing, I'm going to show you what you do if you have the problem just like me with the frame rate. Go to our proprietary graphic drivers. For me, it was on the open source one using Xorg server. Just changing to the latest version of your graphic card. For me, it's NVIDIA, and I'm going to change it to the highest version number available. After you select that, you should restart your computer and it will be okay to go. But I'm not going to do that because I'm not going to stop this recording for you. After that, I will restart. Then we continue with the second step, which is using a test file, a test shell file that is already available in Ardupilot directory. It will connect the flight gear to the flight gear with quad version of Ardupilot. Very simple. Just copy and paste and cd to the folders Ardupilot tools autotest. Then we're going to open this shell file. There are two versions, shell file for a copter and a shell file for plane. Again, source, for example, we're going to use quad here, fg underscore quad underscore view.sh. It will go on and open the flight gear for us. And after that, we are going to open the simvehicle.py to run the Ardupilot firmware. And just to show the world of San Francisco airport, we get pass it the name of Kilo Sierra Foxtrot Oscar to load it in San Francisco airport. First time it will take a little more long time, and also I have the graphic card problem here, so you won't see a very decent view here. Here it is. This is the flight gear. The environment hasn't been modeled because of my graphic card, but it's working. I'm going to create a new tab here with Ctrl Shift T and run the Ardupilot simvehicle.py. First we should cd to the Ardocopter. Great, and almost connecting. Yes, extended Kalman filters is ready. Now you can continue with your console or use QGround. You can go on and play with these settings: autopilot setting, environment, wind, turbulence, location, selecting the airport, views, equipments, multiplayer to model multiple UAVs here. You have lots of capability here. Okay, I think everything is ready. I can command to arm the throttle. You see the motors are spinning, and take off with 5 meters. I don't know why it didn't arm. Maybe because it took me a long time, or maybe because I wasn't in the mode guided. First arm the throttle, then take off, again with 5 meters. Yes, it's took off. We are airborne. You can see the altitude of 10 meters. Why 10 meters? And I told it to be 5 meters. I don't know what is happening here. You can change the weather, time. You can use live meter for the weather. Very great capability here. Okay. And you can also use the QGround near this in parallel to have the commands from QGround as well. And I'm going to tell it the command to land. Because the graphic environment is not loaded, you can't understand that it's actually what is actually it's doing. I'm going to change the mode to guide, change the mode from guided to land. And as you can see, it's landing. Altitude is decreasing. I'm just giving you the concept, but I'm not familiar with this very much. I'm just starting. Okay, I think that's enough with flight gear. And one last thing here. One last thing, I'm going to install Mission Planner on Linux. As I told you, Mission Planner is much more advanced and it's much more advanced for Ardupilot, and maybe you like to test it on your Linux as well. But Linux by itself doesn't support Mission Planner because Mission Planner is based on .NET framework. But there's a tool for that. You can use Mono, and you can use the full version or the smaller version. I'm going to install the full version. Mono will simulate the .NET environment for us, and you can run many of the applications that you run on Windows on Linux as well. I'm going to install the Mono. So I let the Mono complete version install, and after that I'm going to install the latest version of the zipped version, not the installer, the zip version of the Mission Planner. The link is already available here. While the Mono is being downloaded, I'm going to download the Mission Planner as well and put it somewhere I want. You see, this is the folder. After downloading and extracted that folder and put it on my root home directory. After the Mono installed, I SITL Mission Planner and simply run the command mono missionplanner.exe. Don't expect it to work just the same as you have on Windows. There may some functionality problems, some errors, some conflict errors, as you can see here. Windows XP, what the hell? What does it have with Windows XP? And there's also an error, and I don't know. It's about collection is read-only, not support. I don't know what it is about, but no problem. You can cancel it, and it will be loaded up. The map will be loaded in a few seconds or minutes. It's the first time that we have opened here. This is the version of Ardupilot inside Mission Planner. Mission Planner still works with QGround as well, but it's designed specifically for the Ardupilot, but it works with Mission Planner as well. Some people may like this view, some people may like that view. I think Mission Planner is usually for the developers and the advanced user for initialization and the settings usually. But by the time in 2020 I'm talking about this, maybe in next year QGround become more powerful. There's also some software in the loop simulation ready available here inside the Mission Planner. Okay, while Mission Planner is open, let's do the SimVehiclePy and open our simulation inside Mission Planner, just like what we had in QGround. So in another tab for terminal, I cd to Ardupilot, then Arducopter, go to Arducopter, then we run the command for simvehicle.py and again in San Francisco. Okay, Ardupilot software in the loop is ready and it's working. Now the next step is to connect our Mission Planner instead of QGroundControl. Connect our Mission Planner to the Ardupilot software in the loop. Mission Planner has also a connection mode for auto, but I usually don't use auto because it takes a long time and sometimes I'm faced with errors. So I'm going to specify it to connect especially to which communication way. As you can see, it has some compatibility issue. Maybe it's because of my graphic card driver, maybe it's because it's mono, I don't know. Okay. I'm going to close Mission Planner and open it again. This time it works better, I think, but again we saw this error. Let's say no and continue with the Mission Planner. As you can see, the map is starting to load Instead of auto, I'm going to put it on UDP, which is the port that I'm connecting. I will click on connect and will ask me about the local port, which is 14550. It can be checked when you connect the Ardupilot. It will show you what port it's using. And that's done. We are connected in software in the loop in San Francisco airport, and with the quad exactly on the runway, on runway 23. Interesting. You can see the port numbers here on the left side. Okay, whatever we did before, we can do it again here. We can come to actions, arm the vehicle, put it, for example, say takeoff, and takeoff altitude is 5 meters. It starts to take off. You see, this window is usually better for developers. You see many things here that's not important for a user, but it's important for a developer to see all of them at the first, at this one site. Okay, you can set it on guided and say go to here. You can change the parameter. The best part of Mission Planner is this side, full parameter list. Give you a great capability of changing everything inside the Ardupilot configuration and the PID tuning and so on. Okay, that's everything about Mission Planner here. I think we don't need anything else here. And again, you see Autopilot is somehow crashing. So I totally suggest you that don't use Mission Planner with Mono for real flight. Maybe you face with any errors, I don't know. Don't do it for real purpose. Maybe you face with an error just when you are flying, you face with this kind of errors and compatibility issues. And one last thing that I want to cover here is just adding a shortcut for you to have the mission planner and not always run the command of mono. Using the plugin called Genome, you can create a shortcut of anything inside your desktop, and that's good to work. Just quickly, I'm going to install this Genome and the password. You can create a shortcut of any commands with this. Then you run this command. After it installed, you run this command, and you face with this error. The type of the shortcut is an application. The name can be Mission Planner. The command is mono missionplanner.exe. And the sign at the beginning means using from home. I don't know if it is going to work like this or not. This is the Mission Planner folder. I'm going to assign a picture for the icon. Okay. And it should be available on the desktop right now, but I don't know why the icon is missing. We're going to investigate why. You see, nothing is expected here when you work in Linux or generally programming and working with computers. Nothing is expected. You should expect everything. I have done this many times and I don't know why it's not working right now. Maybe this time with icon file. I don't know. Okay, the first time that we okay and give the trust icon, the trust button, the icon appeared, but it's still not working. I think the problem should be with the location address. Okay, I found a solution. Just as I told you, I should have removed this and just giving the address from home directory, and it's okay. Now you have a shortcut that you have no one can understand that this is not a Linux application. You just double click. Okay, thank you for watching. That was it. I hope it will be useful for you. All I did was just gathering all the resources available online, and by the time that we are speaking right now, March 2020, we all struggling with coronavirus and this kind of things. I hope those of you that will watch this video maybe a few years later have no idea if the world has been saved from coronavirus or not. If you're watching this video a few years later, maybe something has been changed. Maybe you need some extra steps. Maybe Mission Planner or Ardupilot have been changed fundamentally. So anyway, this is the steps that you need to continue. You need to do to have the software in the loop. This is the first step for simulation. You can continue with robotic and ROS and the tutorials available from Intelligent Quad GitHub page. You can create image processing, simulation, target following, object avoidance, and so on. Feel free to work and try to work with all of this and try to share your progress with people to help others so we all can improve this field for everyone. This is good for all of us. Okay, excuse me if there was any problem with this tutorial, because I have no experience with Linux and it was my first one time and I had many problems this day. We are facing with coronavirus and many other shit things happening here. Okay, please like, subscribe, and share if you like this, and give me a comment if you need anything and you have a question or you have a project that you need someone to help you. I'm here to help you. Thank you very much. Good day, happy simulating and happy flying.